Okay, so the pH scale ranges from 0 to 14. 0 is the most acidic and 14 is the most basic. In the middle, you have 7, which is neutral. And a neutral substance includes distilled water because it has no minerals, and substances that are more basic would include like household cleaners such as ammonia. On the more acidic side, you'd have fruits and stomach juices and battery acid. So what is an acid? An acid is when you put it in water, the substance becomes more hydrogen ion positive, and it decreases in its hydroxide concentration. So a base is the exact opposite. So it increases in its hydroxide concentration, and it decreases in its hydrogen ion concentration. And so these include the numbers 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, and 14. So the other definition that you could do is that acids, they are proton donors. So protons are just hydrogen ions, and bases are proton acceptors and or hydroxide donors. pH can be calculated by taking the negative logarithm of the hydrogen ion concentration. So you do pH equals negative log base 10 of the hydrogen ion concentration. So there's for neutral substances have an equal concentration of hydrogen ion and hydroxide ions. And the difference between each of these numbers is times 10. So 7 would have a times 1 concentration, and 6 would have 10, and then 100, and so on. That would go on either side of this scale.
Le Chatelier's principle of equilibrium states that when a system is subjected to a change in temperature, pressure, volume, or concentration, the system readjusts itself partially to counter the effect of the new equilibrium. This means that when there is a change in temperature, pressure, volume, or concentration, the system will change its equilibrium, go to the side that is higher or lower in order to make the reaction equal. For example, in the two elements, concentration and temperature, they both have inverse proportions. For example, if the products have a higher concentration, the reactants will have a lower concentration. This means that in the equilibrium, let's say when the products have a higher concentration of mass or matter, the reactants will inversely have an inverse reaction, so they will have a lower concentration than the products. This is also true in the temperature aspect. When the products have a higher temperature or more heat, the reactants will have a lower one. In this case, the equilibrium will move over to the reactant side so that the two can be somewhat balanced. This is also true in concentration. When the products have a higher concentration and the reactants have a lower concentration, the equilibrium will move over to the reactant side so they are somewhat balanced.